All right, hey there, Algebra 2B. We are going to go over our 1.3 notes, which is where we are going to be adding and subtracting rationals. Do keep in mind that when we are talking about rationals, we're really just meaning fractions. So it's just a fancy way of saying fractions. Um, Hopefully this video comes through okay. It records well enough. Do keep in mind, I'm on a beach somewhere, so I don't really care. But we're going to go back and, ooh, that's something weird. We're going to review what it means to work with a fraction in adding and subtracting first, just with numbers, and then we are going to bring in some of our letters and make it nice and weird. So to remind ourselves when we are adding fractions and subtracting fractions, you have to have matching denominators. If you think about it, like if we're talking about a piece of cake where you had half this cake, and then you have another cake where you only had a quarter of it. So let's say you had a one chocolate, one vanilla, you had half of one and a quarter of the other. You can't really put them into the same container and then say, hey, everybody freely grab from whatever you want, because honestly, they're just going to grab the other half of cake left. Like anybody out of a right mind is going to pick the bigger piece. So what we do is we try to cut it so it's the same size as the other piece where we have a quarter. We cut this into two different quarters so that now everybody has access to the same piece. So when they're taking it home, this person could take a quarter of the chocolate, quarter of the vanilla, quarter of the vanilla. And so everybody's being treated equally in this instance. I like to think about it in those kind of terms before I attack the numbers or before I attack the polynomials, because that's like the reasoning behind how the stuff exists. When I have a 1/8 plus a 3/8, I'm good to note that I've got matching eighths on both those denominators. So 1/8 plus three more eighths, if you think about it like adding a thing together, 1 plus 3 is 4/8. Now, a lot of people will get in trouble because they'll also add the denominators. You only add the numerator when you're working with fractions. Think of it like a thing. If I said $1 plus $3, you would say $4. In the same way, if 1/8 plus 3/8 is 4/8. So do not add the denominators, just make sure they match. That might be a good thing to jot down for yourself, something to keep in mind. Now, when we've gotten them added together, then we're going to check to see if it reduces. 4/8 really just reduces to be 1/2. So that's really the answer for a problem like that. Now, that's actually in the ideal case. If we look over at the next example, 1/2 plus 3/5, that's not so ideal because there's no nice way to get those to match. Like in the case that I gave with the with the cake that had vanilla chocolate, it wasn't hard for me to slice this to get them to be equal sizes. Halves and quarters make sense to combine or make sense to be able to get them to match. But a 1/2 and a 3/5, how do you possibly cut a half into fifths? Or how do you cut a fifth into halves? When it comes down to a situation like that, if you can't make one nicely match the other, what you do then is you just force them both to become something new. I can turn both of halves and fifths into tenths because 2 times 5 is 10. So if I take the top and bottom times 5 and top and bottom times 2, I am now going to be working with units of 10 rather than units of 2 or 5. And hopefully it makes sense that I'm doing it twice, 5 on top and bottom, 2 on top and bottom, because I want to have equality in my fraction. If I do something to the bottom, I must also do it to the top. So 5 times 1 gets us a 5/10. And then this would be a 6/10, which if we add those together, 5/10 plus 6/10 is 11/10. So this is probably like really dusting off some old skill stuff you haven't thought about in a while. We're going to take this thinking and move it into the next part. So if anything, if you want to pause and practice more problems like this or find an online tool that will help you do that, I recommend doing so at this time. But otherwise, oh, why is it green? We are going to dive right into the next part. So when we are adding and subtracting rationals, which again, keep in mind is just fractions, your process is going to be pretty regimented. You are going to factor each denominator. So you're going to take all the denominators that you see and you're going to factor them because we got to know what we're really working with. Factors tell us what we're working with. You're going to force the denominators to match by multiplying top and bottom. Now I could say numerator and denominator instead of saying top and bottom. Could probably use the proper vocab, but I'm pretty tired. Step 3, you're going to simplify the numerators, whether it is through the box method, which is the one where we do the Punnett square, or the distributive property, which is where we take a number and we distribute it to each thing inside the parentheses. Step 4, you're going to combine your numerators with one big denominator. This is where I took and added the tops and carried over the denominator. And then lastly, you are going to factor the numerator and look for any cancellation. Now, I should probably give you the reminder. When I say factor, I say try to factor. You are not guaranteed to ever actually factor anything. You have to look for them, but you don't have to guarantee success. If I asked you to factor, or if I asked for the factors of 10, you could say 2 and 5. But if I asked for the factors of 7, you can't really come up with anything better other than 1 and 7. So I say try to factor the numerator. I'm going to tell you to do it, but I can't guarantee you succeed in the process. Try your best. And sometimes you don't succeed. You get what you want, but not what you need. All right. Add or subtract each of the following. Adding, subtracting fractions work the same way. It's really just follow those steps. So factor the denominators, x plus 4 and x plus 4. All right, done, boss. Those are already factored. I can't do a GCF. I can't do an asterisk, nothing like that. Step 2, force the denominators to match. Cool, they already match. Step 3, simplify the numerators, whether it is the box method or distributing. Well, since I didn't have to make them match, I don't have to simplify. This one's going pretty quick. Step 4 is where we're actually going to do some work. Combine the numerators with a single denominator. Okay, so we're going to put the x minus 3 plus the x minus 2, so adding the numerators over a single denominator, x plus 4. So if you need, compare this back to 1/8 plus 3/8. We added the 1/8 and 3/8 to make a 4/8, and then we look to reduce. Here, we added the x minus 3 and the x minus 4, like the 3 plus 1, and it's over x plus 4, a single denominator. So from here, we're going to actually simplify this. X minus 3 plus x minus 2, we're just going to combine our like terms. We have a 1x and a 1x to make a 2x, a negative 3 plus a negative 2 to make a negative 5 over x plus 4. Now our last step, number 5, is to try to factor the numerator and look for any cancellation. 2x minus 5, there's no GCF, there's no difference of squares, there's no asterisk, so it's stuck the way it is. We circle it and we have our answer. Now I can guarantee you there's probably not going to be too many problems that just have their answer this quick. I just wanted to show you that, like, just because something looks scary doesn't necessarily mean that it work is going to be scary. If the denominators already match, wow, you've got a perfect question. Easy peasy. Looking ahead to the next one, we've got a subtraction this time. So running through our options, there are factor the denominators. X squared plus 1 doesn't factor. It looks kind of like it's a difference of squares, but it really doesn't, because it's a plus, not a minus. Difference of squares needs a difference, needs a minus. So that's not going to factor, and it's really going to go down the same path that this one did. So we're going to subtract the numerators, 3x minus 4 minus 6x plus 1 over x squared plus 1. We are going to subtract. Now, if you remember, when we are subtracting problems like this, we perform what is known as keep, change, change. There's a real throwback there. You keep everything in the first parentheses the same, and you change the sign of everything else. So 3x minus 4 plus negative 6x minus 1 all over x squared plus 1. Now that they are an addition problem, we can add them. 3x plus negative 6x makes a negative 3x. And negative 4 plus negative 1 is a negative 5 over x squared plus 1. Now, I'm supposed to try to factor the numerator. So negative 3x minus 5, not really anything useful in common. I could divide away a negative 1, but it doesn't really change anything. So no GCF, no asterisk, no difference of squares. Whatever. Circle it. We had to try. We did not guarantee success. But if you don't try, that's when you get in trouble. This next one is kind of cool. Cool in math sense, I guess. It's a monomial over a monomial. There's no real factoring that has to take place here because there's only a single term and a single term. There's no factoring to break it apart. But this is our first case where the denominators do not match. Big spooky. So we need to find a way to make them match. 8 and 5, there's no nice way to change one into the other. I can't just like times by 2 to get to match, but I can make both of those numbers into a 40. So I'm going to times the 8 by a 5 to get a 40 and the 5 by an 8 to get to 40. Now, I'm also going to need to make sure their letters match. This one has an N, whereas this one has an M. So if I multiply by M on this one and N on this one, each one is going to have one M and one N. And whatever I do on the bottom, I must also do to the top. So 5M times 3M is 15M squared over 40MN plus 7 times 8 is 56N over 40MN. And now that my denominators match, I can add the numerators. 15M squared plus 56N over 40MN. And ideally, I would be able to factor, but there is no way I'm going to factor that numerator. So I just got to let it be, circle my answer. The next one is where we really get into like the meat of these problems. You may notice, if you pause especially and take a moment to look at it, this x squared plus 3x minus 4 is something that we could actually factor. This is an asterisk. So what I'm going to do, I've got a tool for this. Let me play. Let me do my thing. Bam. Okay. Oh, to make a fool of myself. What did I do? Panic. Haha. Okay. You can do this. Button. 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 What do? Move. No, not move. Panic. Why is this ruining my life? What have I done? And now it's all recorded too. You know what? Sometimes you just got to take the loss, guys. All right. So factoring x squared plus 3x minus 4. I can do that with an asterisk. X squared has a 1 in front of it, so 1, 1, -4, and 3. Factoring this, we multiply a 4 by a -1 to get -4 and add to get a 3. So my real factors are 1 over 4, which makes a x plus 4, and a 1 over -1, which makes an x minus 1. Now, I like to mark out the denominator that's there and write the factors instead, because those are what I'm actually able to use. And if you look at our factors now, you should see that something is similar on the next fraction. Both of these fractions have an x plus 4 on bottom. So they already agree on x plus 4. All that I need to do is get them to also agree on the x minus 1. So if I times this by x minus 1, now they both have it. And then I'll be able to add my results together. Now, in order to make that happen, I'm going to carry down the x minus 3, x plus 4, x minus 1, plus. I'm not actually going to times the x plus 4 by the x minus 1. I'm just going to write them both down. Because if I did times them, I would just turn it back into what it was before. But on the numerator, if you notice, one of our steps in our process is to actually simplify the numerator. The way that I'm going to do that is by distributing the 2x to each of those terms in the parentheses. 2x times x gets me a 2x squared. And of course, it's green because why not? 2x squared. And then 2x times -1 is minus 2x. Okay. So now that I have the same denominator, I can write it as two numerators added together with one denominator. So x minus 3 plus 2x squared minus 2x all over a single x plus 4 x minus 1. Your hand's going to get real tired by the time you do these problems. All this writing. And since it's an addition problem, I can add my like terms. So 2x squared has nothing in common, so 2x squared. X plus -2x is minus 1x, and -3 carries down with an x plus 4, x minus 1 on bottom. The last thing you should do in a problem like this is to check to see if the numerator factors, because if it does, we may be able to cancel something. So I would think that our best process for that would be an asterisk. Where are you, green? And we're taking 2 times -3 to make a -6 for the top, 2 for either side, -1 for bottom. -3 and 2 multiply to make -6, and they add to make -1. Now, if you remember how this works for factoring, we are supposed to simplify each side. So 2 over 2 simplifies to be a 1 over 1. If I bring my results over here, we'll see if something cancels. And this should be towards the end of the problem. We've got 2 over -3, so 2x minus 3. 1 over 1 would be 1x plus 1 over x plus 4 and x minus 1. And we're supposed to check to see if there's anything that is similar on top and bottom that I could cancel. Now, maybe I shouldn't say similar. They should be perfectly matching. We're so close to having something perfectly match. You may notice that x plus 1 and x minus 1 are very close to matching, but they don't match. So even though we were able to factor, we still weren't able to cancel anything. So we circle our answer and we are done. Now, if we look at that, that was a lot of stuff, but each step that we did here was one thing that we've already learned. What we're doing is just taking a bunch of stuff we learned and putting it together into one problem. Factoring with an asterisk, we've already done. Distributing, we've done. Adding our like terms, we've already done. Factoring with an asterisk, well, hell, we just did it up there, so yeah, we already did that. It's just the amount of stuff that we've already practiced piling together that makes this seem like a bigger problem. But if you take it piece by piece, each one of these is a skill that you've already passed a class for. You've already done the test. It's just putting it together and stop panicking so that you can try to get it put together, so you can try to get the problem solved. I will be the first one to tell you that this is not the easiest math that you're going to be doing. But there's a certain satisfaction I feel when doing something like this, because it's like that culmination. You've taken all the power that you've earned up to this point, and you are just blasting the board apart with it. So, nerdiness aside, let's do some more math. All right, there's two more problems. I would challenge you guys to pause and try these. I'm going to go through them after a moment. Last chance. Your chance is gone. X squared minus 9 is a difference of squares. If we square root x squared, we get x. And if we square root 9, we get 3. So this is really x plus 3, x minus 3. And this one's already got an x plus 3, so all it's really missing is the x minus 3. So if I was to continue this down, 2x squared minus 30 over x plus 3, x minus 3, minus, I've got an x plus 5 times an x minus 3. That's not distributing. If you have 2 terms times 2 terms, that's a box. We got to draw the Punnett square, which is another skill we've had to practice in the past. X plus 5, x minus 3. X times x is x squared. X times 5 is 5x. Negative 3 times x is negative 3x. Negative 3 times 5 is negative 15. Now, if I add my like terms in the diagonal, I get an x squared plus 2x minus 15 over x plus 3 and x minus 3. Now that our denominators are the same, we're going to combine the numerators into one big fraction. 2x squared minus 30 minus x squared plus 2x minus 15 all over x plus 3, x minus 3. Since I have a minus, I'm going to perform a keep change change. So keep the first parentheses the same. Change the minus to a plus. Change everything in the second parentheses to the opposite sign. So negative x squared minus 2x plus 15 all over x plus 3, x minus 3. We are now going to add our like terms together. 2x squared plus a negative 1x squared would result in a 1x squared or just x squared. We have our minus 2x, and a negative 30 plus 15 is a negative 15 over x plus 3, x minus 3. The numerator is the last thing we have to try and factor now that it's all together. That is going to be another asterisk. 1, 1, negative 15, and negative 2. The two numbers that multiply to be negative 15 and add to be negative 2 are a negative 5 and a 3. So our numerator is x minus 5, x plus 3, all over x plus 3, x minus 3. Well, hey, this is our first instance where we've got something that's the same on top and bottom. So if I cancel those out, I would have x minus 5 on the top and x minus 3 on the bottom. Now, ideally, we would remember to list the restriction. We don't want x plus 3 to equal 0. So in reality, x would not equal negative 3. But honestly, if you did so much work that you got to this part and you forgot the restriction, I think I'd just go ahead and forgive you because quite a few steps. Whoever's panicking, stop panicking. I can hear you from here. Our last problem, 3x minus 2 over 2x plus 5 minus 2 over 5x minus 2. On this one, I can't factor either denominator, so they're kind of stuck where they're at. The only way forward for me is to just multiply by whatever the other one's missing. So in this case, I'm going to times this one by 2x plus 5. 2x plus 5. And then on this one, I'm going to times by 5x minus 2. That way, each one will both have a 5x minus 2 and a 2x plus 5. It's one of those more rare instances where you have to just times everything by whatever you can. So for the first one, I'm going to have a 5x minus 2 on bottom and a 2x plus 5. But for the top, I should really simplify this. If you notice, there's 2 things times 2 things. So bring out that box. We've got, what's happening to me? Oh no. The board is revolting. So 5x minus 2, 3x, 3x minus 2. Timesing, we get a 15x squared, a minus 6x, a minus 10x, and a plus 4. And if I combine my diagonals, a negative 6 and a negative 10 will get me a negative 16. So 15x squared minus 6, I think I said 16, 16x plus 4. And then to make this a little bit easier for ourselves so we don't have to do a keep change later, what you could really do is treat this negative with the 2. So it's really just a negative 2. And we're going to distribute that to each of these. So we're going to change it to a plus. Really, that's kind of the keep change aspect of this. Negative 2 times 2 is a negative 4, so negative 4x. And negative 2 times 5 is a negative 10. And on bottom is 5x minus 2 and 2x plus 5. All right, now that the denominators match, we're going to add, we're going to make it one big fraction with addition. 15x squared minus 16x plus 4 plus negative 4x minus 10 all over 5x minus 2 and 2x plus 5. Since we have addition, we're going to add our like terms. So 15x squared has no like term. Minus 16x is going to have a negative 4x, so making negative 20x. And a 4 plus a negative 10 is a negative 6. over 5x minus 2, 2x plus 5. And so we are finally at the stage where we are able to factor the numerator and look for anything that might cancel. 15 times negative 6 is negative 90. 15, 15. And we have a negative 20 on bottom. We need two numbers that multiply to make negative 90 and add to make negative 20. You might look for a little bit, and hey, I even had to grab a factor sheet for myself, but we've got 1 and 90, no good. 2 and 45, no good. 3 and 30, can't make a 20. 5 and 18, nope. 6 and 15 is close. You could get a 21, but still no good. 9 and 10, 19, no good. This problem psyched us. It said, ha ha, thought you could, but we can't. So we come over, circle our answer, collapse on the floor, breathe a heavy sigh of relief, and we are done. Whew. So a variety of skills that you guys have already practiced, you've already shown mastery for, but you're combining them and you're throwing them together, and we're trying all kinds of stuff here. This is about as difficult as the algebra for the entire class is going to be. Like in terms of the sheer steps and the things you have to remember and put together. From here, we may teach new things entirely that will be difficult, but there's never going to be this level of it like exhaustion from a problem where it's just step after step after step. This is the marathon of math problems for the class. So hopefully it makes some kind of sense. It's worthwhile for you guys. I hope to see you soon. After this, there's no more lessons for Unit 1. So you are just going to be practicing on the review. After the review, you will be taking your test. So remember, you're allowed to use one page, one side. A toolbox is what I call it. Piece of printer paper. On the front side only, you can write whatever you want. Whether it is examples, it's formulas, it's helpful hints. I used to leave myself hate notes. Whatever works for you. Write it down, one page, one side. You can use that on the test. You can use a calculator, the toolbox, and a factor sheet. That's it. No phone, no friends, nothing. You're on your own. But you can do this. I believe in you. All right. Love you guys. Bye.